Hello everyone, welcome to today's class. Today we have a nice Diophantine equation. How do we solve this Diophantine equation? On the board before us here, the question reads m to the power of 2 plus 2 bracket open 3 to the power of n close bracket equal to m open bracket 2 to the power of n plus 1 minus 1, yeah, close bracket. Here we are given some conditions here. M and N are positive integers. And for N, we have N is less than or equal to 5. So how do we solve this Diophantine equation for the integer values of M and N? So if you're new here, this is Online Maths TV. If you've not subscribed, subscribe. Because we roll out nice math challenges, solution to math problems all the time. So without much waste of time, let's go into today's challenge. So yeah, the first thing we do here is to take a solution. To every problem, there's a solution. So now, let's put that the question here. We have m to the power of 2 plus 2 into your 3 n close bracket equal to your m bracket, your 2 to the power of n plus 1 minus 1 close bracket. Now we have to look for the range of values for our n. So from here we discover that our n is equal to 0, 1, 2, 3, 4, and 5. Okay, given this condition. All right, so what do we do here? We put the value when n is equal to 0 into this equation. And that will lead us to a quadratic equation. So we solve quadratically. Now, let's take the first one because we're going to arrive at the answer that is not needed based on this statement. But let's just clarify it. So we now have here 4n equal to 0. Let's bring our equation. So we have n to the power of 2 plus 2 bracket your 3 to the power of 0 close bracket equal to our m into 2 to the power of 0 plus 1 or minus 1 close bracket. Easy. Again, so anything to the power of 0 gives us 1. We all know that. So the whole of this will give us 2. So here we now have m to the power of 2 plus 2 equal to, here is going to give us here 1. So 2 to the power of 1 will give us 2. And 2 minus 1 will give us 1. So here will give us m. So we have this to be m. If we rearrange, we're going to have here m squared minus m, yeah, there plus 2 equal to 0. Now this is a quadratic equation. If we solve this quadratic equation, we are going to have imaginary root for our n. Again, look at what we are asked here. Positive integer. So we discard the solution to this guy here. Now again, if we put our n to be 1, we are still going to have an imaginary root. I've done that already. Okay, then if we go ahead again to put our n to be 2 into this equation, okay, which is our original equation here, if we put our n to be 2, we're going to have negative integer, but we don't need that. So I've worked all this through and I discover that it is only this number and this number here that will give us our m to be positive integer for m. And so let's take that of what? When n is equal to 3. So from here, let's continue on this side. So we now have here 4n equal to 3. We have our m remains. So working with this, so m to the power of 2 there plus our 2 into 3 into the power of 3 there equal to m into our 2 to the power of 3 plus 1 minus 1 close bracket. 3 to the power of 3 will give us 27. And here we add this to give us 4. So 2 to the power of 4 will give us 16. So we now have this to be m to the power of 2 plus 2 into 27 close bracket equal to m, don't mind my hand right here. So we have here 16 minus 1. So we end up having m squared, then plus this will give us here 4. So we have 54 equal to m times 15. Easy. So if we bring this to this side, we're going to have m squared minus 15m, then plus 54. Everything equal to 0. Now, this is a quadratic equation. So let's go ahead and solve this quadratic equation and see if we're going to have our m to be positive integer here. Okay, so now if we look at this, if we bring out the factors of 54, then think of two of them that when multiplied together will give us plus 54, add together will give us minus 15, that will give us minus 6, minus 9, right? So we can rewrite this expression here as our m to the power of 2 minus 6m minus 9m plus 54 equal to 0. So we can put this in bracket, put this in bracket, factor out m here. So we now have m bracket m minus 6 close bracket minus what is common here is 9. So we have 9 bracket, we left with m minus into plus will give us minus, here will give us 6 because 9 dividing 54 will give us 6. Everything equal to 0. So discover that we here are the same. So we pick one, all right? So this now give us m minus 6 bracket bracket m minus 9. Everything equal to 0. So we can equate this to 0, equate this to 0. So if we do this, this now gives us m minus 6 equal to 0 or m minus 9 equal to 0. So therefore, we now have our m equal to 6 or 9. Okay. So we discovered that these are positive integers. So we have our m1, m2. So it's 6 and 9. Now, like I said, I've checked for this. This will give us negative integer. So we want to check for this now. What will be the value of this? So let's say when or for n is equal to 5. So when n is equal to 5, what will be the value of m? So let's keep this and continue on this side of the board. Again, from our equation, we're going to have our m to the power of 2 plus 2 into 3 to the power of 5, right? So to the power of 5 close bracket equal to our m into 2 to the power of 5 plus 1 minus 1. Okay, so we have m squared plus 2 into 3 to the power of 5 will give us 243. Yeah, 243. So we have 243 close bracket equal to, now if we add this 5 to this one, that will give us 6. So 2 to the power of 6 will give us 64. Now 64 minus 1 will give us 63, right? So we're going to have here 63m. All right, so we can use this to open this now. So we now have m squared plus, here we give us 6, here we have 8, and here we have 4. So equal to 63m. Rearranging, we have m squared, then minus 63m plus 486. Everything equal to 0. Again, this is a quadratic equation, right? So how we solve this now? We can use the factorization method to solve this. We bring out all the factors of 486, and among these numbers, let's look for two of them that when we multiply together will give us plus 486, and their addition will give us minus 63. So what will be the two numbers here? The two numbers are going to give us 9 and 54, right? Yeah, that will give us 9 and 54. All right, so we can rewrite this as our m squared minus 9m minus 54m plus 486. Everything equal to 0. Now you know that because if you add this to this will give us 3. Yeah. All right. So we have this. So let's bracket this, bracket this, bracket this, and bracket this. So what is common to both sides here? We have m into this. We are left with m. Then minus here we have 9, and here what is coming here is just 54. So we have 54 there. Bracket here we have m again minus and plus we have minus, and 54 into 486 will give us 9. So we have 9 here, close bracket equal to 0. Are we learning something here? Yeah. So what are we doing next here now? These are the same. So it all means that here we now have our m minus 9, close bracket, bracket. Take this one outside, 9 minus 54, close bracket, everything equal to 0. Again, let's continue on this side of the board. So we have m is equal to, we have 9, comma, or let's use or, let us not use comma, or 54 or 54. You get that now? All right. So we've also gotten another value for our n, and you discover that these two roots are positive integers. So you now discover that the only values of n that will give us positive integer for our n are 3 and 5. Okay, so what then will now be our solution, which is the value of m and n? So we now have m, comma, n will now be equal to, now our first value, remember? So we have our 6, right, comma, 3, and we have 9, okay, comma, 3. Okay, then here we have our 9 for 5, so we have 5, comma, the last one we have 54, comma, 5. So these are the values, okay, of our n and n that will satisfy our Diophantine equation. Now, in my videos, I have discovered there's one of my a viewer, a subscriber that always asks me to check for the authenticity of the roots or the solution to my challenges. Now, we want to check if these 4 pairs of root or solution satisfy the original equation here. I'm going to check for only this and this. On your own, check for this. We satisfy it. All right, so we now take check. So for our n, we have your 6, 3, comma 3. What we do, we pick our equation. What is the equation here? We have here m to the power of 2. So what is our m? Is 6 here. So we have 6 squared plus 2 brackets 3 into our n is 3. So 3 then equal to 6 into we have 2 to 3 plus 1 minus 1. Okay, so here we give us 36 plus here we give us 27, right? So 2 times 27, that will give us 54. So we have 54 then equal to here we have 6 into this will give us 4. So 2 into to the power of 4, 2 to the power of 4, that will give us 16, right? Then 16 minus 1 will give us 15. So we have here 15. Okay, so let's add up this now. So this plus this will give us 0, and this plus this will give us 8 plus the one carry is 90. So here we have 90. This is equals to 6 times 5 will give us 30, carry 3. 6 times 4 will give us 6 plus the 3 carry, we have 90. So this shows that the first one now, which is the first pair, satisfy the original equation, which is this. Okay, again, let's check for your n. So for your n, m9 and n3, then we take our equation again. Here we have, here will give us 9 to the power of 2, then plus 2 brackets, your 3 to the power of 3, close bracket equal to 9 into your 2 to the power of 3 plus 1 minus 1. So here we have 81 there plus your 2 into 27 there equal to Here we have 9 times. This time we're going to get the same thing, right? Which is 15. So here we have 15. So here we're going to have your 81 plus your 54 as we go from the other side. Then let's multiply systematically. 9 times 5 will give us 45. 9 times 1 will give us 9. Plus the 4 you carry, we have 1, 3. Then we come in here, let's add this plus this will give us 5. Then 8 plus 5 will give us 13. So we have 13. So we now have this to be 135. So you also discover that this also satisfies the original equation. So on your own, you can go ahead to check for this and this. All right. Wow. So this marks the end to this wonderful Diophantine equation. If you learn something from the solution, the approach I applied in solving this Diophantine equation, give the video a thumbs up. And you have a better way of solving this so that we can learn from you. Drop it in the comment section. Okay? You don't have any issue with the method applied here, but you like the method of explanation, still drop it in the comment section. See, we love you. You try, do more, do that, do that. We love you. We love you. Guess what? All of us at All I Must TV, we love you so much because you are the reason for the existence of the channel. Bye for now.